With the Iraqi invasion of Kuwait, a great confrontation began as a host of forces from around the world were deployed against the Iraqi army. This video ordnance program looks at the weapons of Operation Desert Shield. The Iraqi invasion of Kuwait pitted the largest army in the Persian Gulf against one of the smallest. The Iraqi army, hardened by a decade-long war with neighboring Iran, numbers over 650,000 men against a Kuwaiti force of only 10,000. Even the vast kingdom of Saudi Arabia has only 95,000 troops in its army and national guard. It was the threat that Iraq might extend its invasion beyond Kuwait into the oil-rich Saudi lands that prompted the anti-Iraq coalition to deploy in Saudi Arabia, codenamed by the United States Desert Shield. But just how good is the Iraqi army? Seth Karras, a noted specialist on Mideast military issues, describes the performance of the Iraqi army in the Iran-Iraq War, waged from 1980 to 1989.
The Iraqis showed a very mixed picture during the war. They sometimes did very well, they sometimes did very badly. They had a lot of problems. One of them was political interference. When Saddam Hussein interfered in military operations, things often went extremely badly. When he kept hands off and left things in the hands of the professional soldiers, they often did quite well. In addition, it depended upon the circumstances. The Iraqis were never extraordinarily good at mobile warfare, but they did learn during the course of the war, and by the end of the war, they were much better at it than they had been at the beginning of the war. They also learned over the course of the war a whole lot about fighting defensive operations, so that by the end of the war, they were very good at building fortifications and equipping them and manning them with troops.
The Iraqi army is organized into about 7 tank divisions, 3 mechanized divisions, and 50 infantry divisions. With the invasion of Kuwait in 1990, the Iraqis shifted their military might away from their former Iranian foe and into a southern direction, facing Saudi Arabia. According to intelligence sources, by the end of 1990, the Iraqis had moved their 25 best divisions, over 350,000 troops, into the Kuwaiti theater. This includes over 3,000 tanks, 3,000 armored vehicles, and 2,000 artillery pieces. The shock force in these actions was the elite Republican Guard.
The Republican Guard started totally as a defense of the regime type force. It existed for political reasons, and that reflected the fact that essentially every government in Iraq has changed because of a coup, so that there's a tremendous desire on the part of the current regime to have means of keeping the military under control. For most of the time in the last 20 years, the Republican Guards has been a fairly small force, growing over time, but never that large. During the latter part of the war, however, especially in the last few years, it was greatly expanded. So it now is a multi-divisional force, including armor, infantry, commandos, that in fact is the elite shock part of the army. It still has a political role of defense of the regime, which is why the Iraqis kept portions of the Republican Guard sitting in Baghdad even as they were invading Kuwait. But it also has this critical military role. It's the best part of the army, even though there are other parts of the armed forces which are good. I mean, there are some good mechanized armored units in the regular army. There's some good commando units in the regular army. But the core strike force is the Republican Guards.
Iraq's military equipment is nearly as diverse as that of the forces facing it. During the mid-1980s, Iraq purchased $30 billion of arms from abroad. By far the largest share came from the Soviet Union and its Warsaw Pact allies. France was the second largest supplier of arms, with much smaller amounts coming from NATO countries such as Germany, Italy, and Britain. China sold Iraq over $3 billion of weapons. Countries new to the arms trade flocked to Iraq to sell their new military products. Brazil, North Korea, and Yugoslavia sold $5 billion of weapons to the Iraqi armed forces. American arms sales to Iraq were nearly non-existent. To counter the Iraqi invasion of Kuwait and to prevent further Iraqi aggression, a multinational force led by the United States began deploying in the Gulf region. The largest contingent is from the United States, including over 250,000 Army and Marine troops. Syria has pledged 19,000 troops, with similar numbers coming from Egypt. European contingents include about 30,000 British troops and over 15,000 French. Other contingents were deployed from over a dozen other countries. Desert Shield is the largest massing of land, naval and air power ever seen in the Gulf region. The Iraqi Navy is small and does not compare to the sizable forces deployed in the Persian Gulf by the navies of the multinational force. The sea has been the primary means of supplying the armies of the multinational force. The navies are also countering any attempt to resupply the Iraqi army by enforcing the United Nations economic embargo of Iraq.
Merchant vessel, this is U.S. Navy warship, channel 16. Captain, request you shift to channel 10, over.
10.
Here we see an American warship in the Red Sea conducting a boarding of a grain freighter, the Baltic Mermaid, headed for the Red Sea port of Aqaba in Jordan. The warship hails the freighter and inquires about its cargo.
Captain, I also need to find out what your cargo is. Over.
Our cargo is barley and bulk. Barley and bulk. Grain.
Barley in bulk. Captain, I understand that you're a
The captain decides to send a boarding party onto the freighter.
Load the motor whaleboat. Time is over. All right, if you open some cargo hatches.
You can open all the cargo hatches.
The next hardest thing is making sure the paperwork is legitimate and matching the manifest documents and the bills of lading of their cargo with the actual cargo. And we inspect the decks and the cargo holds.
Which one you want?
I want.
Besides their utility in waging economic blockades on Iraq, the naval forces in the Gulf add considerably to the military might of the Desert Shield coalition.
What navies give you in general is mobility, so they can strike from directions other than the ones that he may be prepared to handle. The effect of naval forces is to increase the number of possible strike options, all of which he has to meet. That thins him out. Incidentally, it probably helps thin him out on the ground as well. So, first of all, there are strike options, and that will mean tomahawks and also aircraft. Then, in addition, there will be options for amphibious operations, probably helicopter landings. And it's not just our Navy, but also remember the French have a carrier there with helicopters on board. So, what it presents him with is a more complicated defensive job. Now, in addition, remember that there are carriers in the Mediterranean and the Red Sea. They can launch airstrikes. There are probably also ships with the carriers with the tomahawks on board. The tomahawks can come in from unexpected directions. If we're able to map his airfields and his radar stations in advance, then presumably we can hit them. That helps pave the way for the airstrikes that follow in.
The Navy can influence the land battle with air power from its carriers, missiles from its warships and submarines, and with marine amphibious forces from its assault ships in the Gulf. Navy assault ships like this one carry not only the marine ground forces, but their air support as well, such as the AV-8B Harrier jump jet. The offensive punch of the Iraqi army comes from its tanks. This is one area in which the Iraqis have a numerical preponderance over the forces in Saudi Arabia. But the Allied forces have a qualitative superiority. A third of the Iraqi force is made up of the older Soviet T-54, T-55 tanks and their Chinese equivalent, the Type 59 and Type 69. This tank type dates back to the 1950s and is armed with a conventional 100mm gun. The Iraqis have developed their own improved version of the T-55, including an up-armed version with a 125mm gun and a type with advanced armor. The single most numerous type of tank in the Iraqi service is the Soviet T-62 and its North Korean copy. The T-62 is very similar to the older T-55, but it is armed with an improved 115mm gun. Some North Korean and Chinese supplied tanks have improved gun accuracy due to a laser rangefinder. The most advanced tank in the Iraqi arsenal is the T-72 tank, which amounts to about 30% of the Iraqi tank force. This tank is used mainly by the elite Republican Guard units. The T-72 is armed with a very powerful 125mm gun and is considerably improved over the older tanks in Iraqi service, with better armor and superior gun accuracy. Although Soviet tanks and their copies make up most of the Iraqi tank force, there is a hodgepodge assortment of other tanks captured during the war with Iran, including a few dozen American and British tanks.
Iraqi tanks look very good on paper. If you take a look at the key characteristics of main battle tanks, the gun performance, the thickness of the armor, the mobility of the tank, the Iraqi tanks seem to stack up pretty well against American or British or French tanks. But you have to take a look a little bit deeper than that. For example, the issue of the durability of the vehicle. The Iraqi tanks, mostly coming from the Soviet Union or China, are relatively inexpensive tanks that aren't very durable. As an example, the gun barrel on a Soviet or an Iraqi T-72 tank is good for about 100, 120 rounds before it gets worn out. Now, on a comparable tank, an American or British or European tank, the barrels tend to last 500 rounds, 1,000 rounds. That wouldn't seem to make much difference in battle, but it has a lot to do with training. It means that the Iraqis can't train with their tanks as much as the Americans or the British or the French because their barrels run out, their tracks eventually wear out, the engines wear out. So as a result, the Iraqis don't train as hard, they don't train as often, they don't train as long as the tankers on the other side of the potential battle. What this means is that the Iraqi tankers have less skill in many of the basic combat skills, such as the accuracy of their fire. Another factor to keep in mind also is that many of the Iraqi tanks are very heavily worn out from the last Gulf War, from the Iran-Iraq War, which lasted almost a decade. So I don't think that we should be misled by the simple numbers, by the fact the Iraqis have more tanks. The bottom line is that numbers alone don't tell the whole story, that there's other factors that certainly have to be kept in mind.
The multinational force in Saudi Arabia is equipped with an equally diverse selection of tanks. The tanks of the American and European units are generally superior to those fielded by Iraq. The mainstay of the United States Army units is the M1 Abrams and its improved variant, the M1A1. The M1 Abrams tank is armed with a 105mm gun, which is fully stabilized, allowing it to fire while moving. The improved M1A1 Abrams tank has a larger 120mm smooth-bore gun and is fitted with a new generation of laminate armor. U.S. Marine units used the older M60A1 tank, which was developed in the 1960s. Many have been modernized with additional applique armor to protect themselves against Iraqi anti-tank missiles. British forces, including the famous 7th Armored Brigade, known as the Desert Rats, are equipped with the Challenger main battle tank. It is a new design similar to the American M1 Abrams in size and performance. The Saudi Arabian Army is equipped with the American M60 tank, and both Saudis and French units in the Gulf also use the French-built AMX-30 tank. Although the Iraqi tanks have outnumbered the Allied tanks, the multinational units have enjoyed a distinct technological edge. Take the two top tanks as an example. The Iraqi T-72 is about 40 tons in weight, compared to 65 tons for the M1 Abrams. The M1 Abrams tank is heavier than the T-72 due to its thicker armor and larger interior, which allows more ammunition to be carried. This overhead view of the turrets of the T-72 and the M1 show the real difference. The M1 turret is wider and larger due to its thick layer of advanced laminate armor. The frontal armor of the M1A1 will stop nearly any existing anti-tank missile or projectile. Another difference is that the T-72 has a 3-man crew compared to the 4 in the M1 Abrams, since the T-72 has an auto-loader instead of a human loader. The interior of the M1 tank is more spacious than the T-72, making it more suitable for prolonged combat operations in difficult desert conditions. Most Iraqi T-72s are older models, which do not have advanced laminate armor in the turret, so they are more vulnerable to many types of anti-tank missiles and larger tank guns. Although the basic gun performance of the T-72 and the M1 is very similar, the Abrams has distinct accuracy advantages due to superior gunfire controls. The T-72 can only fire from the halt or while moving at very slow speeds.
Fire control system is excellent. Shooting on the move is better than the 60. The faster the tank goes, the more stabilized the gun is. And you can smack targets. You can ask my gunner. He can hit targets moving at 30, 35 miles an hour without a problem.
One of the unique advantages of the more advanced tanks of the multinational forces is their thermal night sights, a far more versatile sighting system than the types employed on Iraqi tanks. These sights can also be used during the daytime to see through smoke that would blind Iraqi tanks. The Iraqi tank force is not as experienced as other branches of the Iraqi army. Its performance during the Iran-Iraq War was lackluster.
Because of the fact that the Iraqis did not face a serious armored threat, there really was not the need for them to develop the kinds of equipment and the kinds of tactics and capabilities that they would have needed if they were fighting somebody with a real armored force. I mean, if there's a war between the U.S. and Iraq, the U.S. is going to have real armored forces, and they're going to have no experience in dealing with those kinds of forces. So I think this really reflects one of the disadvantageous results of their experience in the war with Iran. If you're just going up against infantry, even a T-55 is fine.
Tanks are not the only armored vehicles on the modern battlefield, and in fact are outnumbered by a wide variety of light armored vehicles. For example, armored attacks are often preceded by armored scout units, which hunt out the weak points in enemy defenses. The Saudi National Guard has used the American-manufactured V-150 Commando armored car. Its wheels give it very good speed in areas of hard desert. The French Army has a larger and more powerful type in the Gulf, the AMX-10RC, armed with an impressive 105mm gun. The U.S. Marine Corps uses a family of light armored vehicles called LAV. The basic LAV-25 is used in the scouting role and is armed with a rapid-fire 25mm Bushmaster cannon. The Iraqi Army uses several different types of wheeled scout vehicles, including the Soviet BRDM-2, the Brazilian Cascaval, and several different types of French armored cars. Infantry is very vulnerable to artillery fire and machine guns on the modern battlefield, and so often rides into combat in armored infantry transporters. The U.S. Army uses the M2 Bradley infantry fighting vehicle, which is the most heavily armored infantry vehicle in service anywhere in the world. The British Army uses the Warrior, which is very similar to the Bradley in most respects. Because of their possible role in naval landings, the U.S. Marine Corps uses a very specialized type of infantry carrier, the AAV-7 amphibious assault vehicle, which has far superior swimming capabilities than conventional infantry vehicles. The Iraqi army is not well equipped with troop carriers. Only a small fraction of its infantry forces have such vehicles. The best Iraqi armored infantry vehicle is the Soviet BMP, which comes in two varieties. The BMP-1 with a 73mm low-pressure gun, and the improved BMP-2 with a 30mm automatic cannon. The BMP-2 is lighter than the American Bradley at 15 tons versus 22 tons for the Bradley. Mobility of both vehicles is similar, though the infantryman in the Bradley is better cushioned from the shocks of high-speed cross-country travel than in the less robust BMP. The firepower of the Bradley and the BMP is similar, both having an automatic cannon and supplementary anti-tank missile launcher. The Bradley weapon system is more accurate at long ranges, and the vehicle carries more ammunition. The infantry squad of both vehicles is usually 6 men, plus a crew of 3 men in the vehicle itself.
Iraq's advantage in land power really is more in the area of the numbers of armored vehicles, the number of artillery pieces, the number of troops, certainly not in quality. And so that raises the question, is it numbers which really determine the outcome of the war? If you take a look at the lessons of recent wars in the Mideast, for example, the war between Israel, Egypt, and Syria in 1973, it's quite clear that the numbers weren't really the determining factor in the war. Rather, it was the skill and determination of the troops. And that is certainly likely to be the case in the Gulf as well.
Air power is one of the areas where the multinational forces have unquestioned superiority. The Iraqi Air Force, although equipped with some first-rate aircraft, faces the most technologically sophisticated array of warplanes ever amassed in the Mideast. The Iraqi Air Force is structured to assist the ground forces in combat. It has over 950 combat aircraft, about 500 of which are attack aircraft and bombers. The remainder are mainly fighters, but many older Iraqi warplanes are in poor repair. The most numerous Iraqi fighter is the Soviet MiG-21 and its Chinese derivatives. This 1960s vintage fighter makes up nearly 70% of the Iraqi fighter strength, but it does not compare favorably with more modern fighters. The Iraqis possess a small force of MiG-25 Foxbat high-altitude interceptors and are rumored to have a few of the more advanced MiG-31 Foxhounds. Iraq uses a small portion of its excellent French Dassault Mirage F-1 fighter bombers in the interceptor role. By far the most capable fighter in the Iraqi infantry is the Soviet MiG-29 Fulcrum, the MiG-29 is technically similar to newer generations of American aircraft, such as the American F-16 and F-18 Hornet. Soviet-supplied aircraft make up about 75% of the inventory of Iraqi strike aircraft. This includes the older Tu-16 Badger and Tu-22 Blinder medium bombers. Sukhoi fitters are the most numerous attack aircraft in the Iraqi Air Force, ranging from the older Sukhoi 7 to the more modern Sukhoi 17. Ground attack versions of the Soviet MiG-23 Flogger make up another quarter of the force. These aircraft carry a wide range of conventional bombs, as well as new laser-guided missiles. Recently, the Soviets have provided the Su-25 Frogfoot ground attack aircraft, an effective close-air support aircraft that saw extensive combat in the skies over Afghanistan. The Frogfoot is similar to the American A-10 tank buster. The Iraqis recently acquired a handful of sophisticated Soviet Su-24 fencers, which give them long-range attack capabilities similar to the American F-111. One of the most capable Iraqi strike aircraft is the French-built Mirage F-1. The Iraqi Mirages are equipped with the Exocet anti-ship missile, making them a significant threat to surface warships. It was an Iraqi Mirage that damaged the U.S. destroyer Stark in the Persian Gulf in 1987. 32 tankers and other ships were damaged or sunk in the Persian Gulf by Iraqi Exocets during the war with Iran. Though Iraq possesses a sophisticated arsenal of modern combat aircraft, its past combat record has been notable for its lack of success in employing these aircraft.
It was a mixed picture. I mean, there were some things that they did relatively well in the air. I mean, there were some rather effective long-range strike missions against tankers in the Persian Gulf, for example. They were able to mount some raids on Tehran with their aircraft, which is a long way to go, carrying even a small payload. So that they were able to do some things relatively effectively. The problem is that the Iraqis really were reluctant to put their Air Force at risk. You know, they conducted, by and large, operations that there was little chance that the planes would get shot down. And that meant, of course, that they never really learned how to do all the important things that Air Forces do. They didn't let them do close air support. They turned that over to the helicopter forces in the Army. And they didn't really do a lot of heavy, effective attacks of the kind that other countries with similar-sized air forces could undertake. I suspect the real problem is that they don't understand what air forces can do and what they're for. Even with the kinds of equipment they had, even with the desire to minimize losses, they still could have accomplished a whole lot more with the equipment they had. You know, you put that same Air Force in the hands of even some other Middle Eastern countries, you know, like the Jordanians or the Israelis, and it would have actually been a very effective instrument. So I think the fundamental core problem is that they really don't understand what air power is all about.
The unwillingness of the Iraqi Air Force to commit its precious strike aircraft to the close air support missions shifted the burden to the Army's small force of attack helicopters. The Iraqi helicopter force uses a diverse selection of Soviet and European helicopters in this role. The Gazelle and BO-105 helicopters were used against tanks with hot-guided missiles. Facing the Iraqi Air Force is a formidable array of the best warplanes developed in Europe and the United States. The Saudi Air Force flies the American F-15 Eagle. Compared to the Iraqi MiG-29, the F-15 is a larger aircraft with greater range and a heavier weapons load. The F-15's radar can acquire the MiG-29 at long ranges before the MiG-29's own radar can see the Eagle. The F-15 Eagle is backed up by the E-3A AWACS, a long-range radar and command center. It can track Iraqi fighters from the moment they take off and coordinate interceptions by friendly fighters. Command and control is a critical but little-known ingredient in modern air combat. U.S. Air Force squadrons in the Gulf are equipped with the F-15 Eagle, as well as the smaller F-16 fighter bomber. The F-15 is a high-performance interceptor which combines sophisticated avionics with excellent maneuverability. Another highly capable interceptor is the British Tornado F-3, flown by the Royal Saudi Air Force and the British Royal Air Force. It is armed with Skyflash and Sidewinder missiles. The small Kuwaiti Air Force, operating from Saudi bases, is equipped with the A-4 Skyhawk and small numbers of Mirage F-1 fighters. Besides land-based squadrons, the U.S. Navy provides additional air power from the decks of its aircraft carriers offshore. The Navy's principal interceptor is the F-14 Tomcat.
The Tomcat is an air-to-air fighter, so its job would be strike escort or protection of ships in the Gulf. And its advantage is the ability to handle several enemy aircraft at one time, the ability to distinguish many aircraft at once on its rather elaborate radar. Possibly it would also provide some kind of forward air control in a combat situation, because there is some command and control capability in the airplane.
Bridging the gap between interceptors and bombers are dual-role fighter bombers, such as the Air Force's F-16 and the Navy's FA-18 Hornet. These can serve as dogfighters to supplement the interceptors, or can carry out ground attack missions in concert with the more specialized attack aircraft. The multinational forces in the Gulf placed considerable emphasis on ground attack aircraft. The Saudi Air Force employs the British Aerospace Tornado GR-1 strike fighter. Compared to the Iraqi Sukhoi 17 fitter, the Tornado GR-1 has a heavier bomb load, 8 tons versus 5 tons, and greater range. More importantly, the Tornado's sophisticated radar navigation attack system allows it to operate day or night in nearly any weather, while the fitter is limited to fair weather daytime missions. Royal Air Force squadrons in the Gulf include both Tornado GR-1 and Jaguar units. The Jaguar is in the same size and range category as the Iraqi Mirage F-1. The Jaguar can carry up to 4.5 tons of bombs, compared to 4 tons for the Mirage. French forces in the Gulf have also deployed the Mirage F-1 interceptor, making it one of the most common fighter types in the region. The U.S. Air Force's principal close-range tank buster is the A-10. The A-10 is armed with a potent 30mm cannon, as well as precision-guided Maverick missiles for attacking hardened targets such as tanks and armored vehicles. The Air Force's deep interdiction mission is performed by sophisticated attack aircraft such as the F-15E Eagle and the F-111. These aircraft have advanced terrain-following radars, which permit fast, low-altitude attacks to better evade enemy air defenses. They can carry out their missions in all weather and at night. The Navy's equivalent of the F-111 is the A-6 Intruder. The most exotic strike fighter in service in the Gulf is the F-117 Black Jet, which is designed primarily for pinpoint nighttime attack of critical high-value targets. The main threat to the aircraft of the multinational force is more likely to be the numerous anti-aircraft weapons of the Iraqi army, rather than the opposing fighters of the Iraqi Air Force.
If you look at the Iraqi air defenses, you're immediately struck by one thing, and that is that they have a large number of pretty much obsolete or obsolescent medium-range surface-to-air missile systems. Even in third-world standards, that equipment is probably pretty marginal. At the same time, they've got this incredible array of short-range air defense systems, large numbers of guns, a lot of decent quality short-range surface-to-air missiles. The disparity suggests two things. First of all, that the threat that they faced was really one that was best dealt with by low-altitude systems, so that they put all their effort into this large mass of short-range systems. Second, I think it also reflects the fact that a lot of that equipment had a dual purpose. A lot of the anti-aircraft guns were used for things other than just shooting at aircraft. They were also used to support the ground forces in defensive operations. So that there was a practical value in having a gun that could be used for dual purposes. This emphasis is going to really come back to haunt them if they have to fight the U.S. Air Force, because we're going to be able to strip away their medium-range SAMs without that much difficulty.
Since antiquity, cavalry had been the dominant arm of battle. The cavalry was the mobile shot force of all successful armies. With the advent of the machine gun in World War I, the horse cavalry finally met its match. It was simply too vulnerable on the modern battlefield. But the important mission of the cavalry still remained. The main distinction between cavalry and other combat arms was the cavalry's superior mobility. To replace horse cavalry, some other type of mobile shock force was needed. Ultimately, 3 new types of mobile forces emerged to replace the cavalry: armored cars, paratroops, and helicopters. In this Arsenal episode, we'll take a look at the types of weapons and units that have taken over the horse cavalry's mission on the modern battlefield. In the past, the cavalry's mobility allowed it to range deep in the enemy's rear area, attacking where least expected. With the advent of the aircraft, a new means had arisen to perform this mission. While it was impractical to land aircraft in the enemy rear, shock troops could be dropped by parachute. So was born the modern air assault force. Paratroopers have become one of the key rapid reaction forces to replace traditional cavalry. Parachutes were invented to save airmen in the event of problems with their aircraft or balloon. But in the 1930s, several armies began experimenting with them for military operations. Parachutes opened up the possibility of dropping a force deep behind enemy lines where enemy defenses were weakest. World War II saw the first extensive use of airborne forces in such famous battles as Iban Imal and Crete. The U.S. Army's best-known airborne divisions in World War II were the 82nd, nicknamed the All-American, and the 101st, nicknamed the Screaming Eagles. These early airborne units used two methods of delivery into combat zones. The best-known and most widely used technique was the parachute. But the divisions also could deliver a portion of their troops as well as heavy equipment by glider. These gliders were towed behind transport aircraft and released near the landing zone. The 82nd's first airborne operation was during the 1943 invasion of Sicily, followed by later combat actions in Salerno and Anzio in Italy. The 82nd earned a hard-won reputation, with the Germans calling them those devils in the baggy pants. The 82nd and 101st took part in the massive airborne attacks that initiated the D-Day invasion at Normandy in June 1944. Their last major airborne drop of the war took place in the Arnhem operation in the Netherlands, where the 82nd Airborne seized the Nijmegen Bridge. In the post-war years, the technology of troop insertion began to change with the advent of the helicopter. Instead of parachutes or gliders, helicopters could now deliver forces deep behind enemy lines. The 101st Airborne was converted over to a heliborne force, now being called the 101st Air Assault Division as a result of this change. But parachutes still have their place in modern warfare. Helicopters can deliver a force a few hundred miles, but are limited by the range of the helicopters. Paratroopers can be delivered to objectives much further, since their transport aircraft have ranges of several thousand miles. As a result, the U.S. Army's Contingency Corps has both a heliborne and a paratrooper division. The 82nd Airborne Division has been an essential element of the Army's Rapid Reaction Forces for over a decade, seeing combat in Grenada in 1983 and in Panama in 1989. In 1990, after Iraq had invaded Kuwait, it was the 82nd Airborne Division that was rushed to Saudi Arabia to draw the line in the sand, signaling the U.S. intention to resist further Iraqi aggression. These operations all highlighted a primary mission requirement of the division, the need to be able to deploy a combat-ready force at a moment's notice. The 82nd Airborne Division maintains a rapid reaction capability through vigorous peacetime training and continuous preparations. At all times, the division maintains a portion of its forces, called the Division Ready Force, on an alert status, ready to go into action anywhere around the globe. With its proud history and demanding mission, the 82nd Airborne has long been considered one of the U.S. Army's elite formations. Like the cavalry of a century before, the 82nd's assignments demand a very high level of military skills. The hallmark of the airborne soldier is the parachute. When going into a combat jump, the paratrooper will be heavily burdened with equipment. Over his regular combat equipment webbing, the paratrooper wears a special harness. The main parachute is attached to the rear of his harness. In front, the paratrooper attaches a reserve parachute, which is a safety backup in case of problems with the main parachute. The airborne soldier's individual weapon is carried in a special weapons case. The soldier's Alice pack, or rucksack, is suspended off the front of the harness. The main parachute is designed to land the paratrooper safely, even during jumps from under 1,000 feet. In total, the paratrooper carries about 150 to 180 pounds of equipment. Upon jumping, the weight of the paratrooper breaks a pack-closing tie when the end of the 15-foot static line is reached. When this happens, the parachute deployment bag comes free of the pack tray. 2 connector link ties then break, and the suspension lines are pulled out of the stow loops of the deployment bag. Finally, 2 locking stows disengage, and the canopy is pulled from the deployment bag. The entire process takes about 4 seconds from exiting the aircraft to full inflation of the parachute's canopy. As the paratrooper approaches the ground, he can lower his equipment to reduce the risks during landing. The inherent risk in parachute jumps has led to a series of overlapping safety features during airborne operations. One of the most obvious methods is the second parachute worn by the paratrooper, called a reserve chute. Since airborne operations are conducted from low altitudes, every effort is made to ensure that the main chute operates every time. Preparing parachutes for operations is the responsibility of the division's 407th Supply and Transport Battalion. During peacetime operations, the paratrooper bundles the parachute into a kit bag after the drop. If this was a wartime situation, the paratrooper wouldn't take time to bother with this. Bundling the parachute after jumps is the first step in ensuring that the parachutes remain undamaged and safe to use. Once the parachute is returned to the main base, it is carefully inspected. Any tears in the canopy are repaired, and any tangles in the lines are carefully removed. Only after the parachute's meticulously inspected is it repacked. The pack facility at Fort Bragg is the largest of its kind in the United States Armed Forces. The paratrooper's safety is the center's key concern. Although the 82nd Airborne is primarily a light infantry force, its missions often demand some heavy equipment, such as artillery and light armored vehicles. All of this equipment must be air-portable. This weaponry includes special lightweight tanks, as well as lightweight versions of towed artillery pieces. This heavy equipment has to be dropped into the landing zone, along with the paratroopers. This can range in size from single containers of ammunition or other supplies, all the way up to armored vehicles like the Sheridan Air Mobile tank. The 82nd uses a variety of special techniques to ensure that the heavy loads will arrive safely in the drop zone. These troops are preparing a Humvee light truck for a parachute drop. The Humvee is loaded onto a special reinforced platform, and it's packed with special shock-absorbing cardboard material. This packaging helps minimize damage when it strikes the ground. Especially heavy loads, such as the M551 Sheridan armored vehicle, require special attention. There are 2 methods for delivering such loads into the drop zone: parachute and LAPES, short for Low Altitude Parachute Extraction System. LAPES allows for the delivery of especially large and heavy loads without the need for so many large cargo parachutes. But it does demand considerable skill on the part of the airlift pilot. The Sheridan armored vehicle is unique to the 82nd Airborne Division. Although originally designed to serve both as an Army scout tank as well as for air mobile operations, the Army is reluctant to call it a tank since it's much more lightly armored than main battle tanks. Instead, it is officially dubbed an Armored Reconnaissance Air Assault Vehicle. It's been replaced in other Army divisions by a cavalry version of the Bradley fighting vehicle. The 82nd Airborne Division is the only unit still to use the Sheridan in its original role. The Sheridan was designed to combine lightweight with very heavy firepower. Its 152-millimeter weapon is a unique combination of missile launcher and gun, capable of firing either a guided Shalala anti-tank missile or more conventional unguided projectile. The Sheridan is the only U.S. Army armored vehicle which is routinely parachuted. The Sheridan crews are a unique breed of tankers, not only needing to be competent as armored vehicle crews, but airborne qualified as well. The unique demands of airborne operations have led the 82nd to stress lightweight and portability in their support weapons. Weapons like these give the division added combat punch. Delivering the paratroopers to their distant objectives is the task of the U.S. Air Force's military airlift units. An important element in division planning is the close relationship between the airborne forces and the airlift squadrons. The 82nd Airborne's North Carolina base at Fort Bragg is co-located with Pope Air Force Base, home of a number of transport squadrons. Delivering paratroopers is not as easy as it might seem. One of the greatest concerns facing airborne commanders is landing their forces in a very tight pattern and avoiding wide dispersion. This means that the airlift aircraft will have to fly in close formation. This is further complicated by the fact that nearly all wartime combat drops and many peacetime training drops are conducted in the darkness of night. Night drops may be difficult for the airlift crews, but they are a definite advantage to the paratrooper. The 1989 Operation Just Cause combat jump for the 82nd Airborne in Panama was a nighttime jump. The darkness of night conceals the paratroopers from the enemy, protecting them while they're most vulnerable. The routine of today's airborne jump would be familiar to a paratrooper from World War II. As the paratroopers wait to board the aircraft, the traditional ritual of all paratroopers takes place. The jump masters and their assistants carefully check each soldier to make certain that no harness is out of place, no line tangled. There is no excuse for accidents. Burdened by the heavy load of their parachutes and equipment, the airborne soldiers struggle onto the aircraft. It's not surprising that the 82nd Airborne places great importance on peak physical training for its troops. Once aboard the aircraft, the paratroopers settle in for the trip to the landing zone. In peacetime, the trip is seldom more than a few hours, but for overseas deployments, it can be over 10 hours. Inside the cavernous hold of the aircraft, the paratroopers anxiously await the signal to get up and attach their static lines. No matter how careful the planning and how thorough the training, there's always an element of danger in parachute jumps. on approach to the drop zone. The pilot signals the jump masters in the rear of the aircraft that the drop zone is approaching. The jump master waits for the green light, and the first groups of paratroopers are soon exiting the aircraft. Like the cavalry from a century ago, the 82nd Airborne Division is the shock force of today's U.S. Army. When a crisis arises, the Army knows it can depend on the combat skills of the airborne. The design of a practical helicopter toward the end of World War II made another form of airborne cavalry possible. Helicopters offer an unmatched degree of mobility, combining speed and tremendous firepower. The most powerful weapons of the Army's air cavalry are the attack helicopters. The idea of helicopters is nearly as old as that of other types of airplanes. Leonardo da Vinci first dreamed of an early helicopter more than 400 years ago. But practical helicopters came about 40 years after winged aircraft. Experimental helicopters flew in the 1930s, but they still had many technical problems. The first military helicopter came on the scene at the end of World War II. The Germans used small autogyros for observation from submarines. The first successful military helicopters were the American Sikorskys, such as the R-4. They were designed by the gifted Russian immigrant Igor Sikorsky. The Sikorsky R-4 saw combat in the jungles of Burma, bringing in supplies and evacuating wounded troops. It wasn't until the Korean War in 1950 that there were enough helicopters to have much effect. In the Korean War, the main role of the helicopter was the evacuation of wounded troops back to MASH hospitals. The French War in Algeria in the 1950s saw the first extensive use of armed helicopters. It was the Vietnam War which proved the value of vertical mobility. The French experiments paved the way for American helicopter operations in Vietnam. The Vietnam War became a helicopter war. Roads were few and were well suited for ambush. Helicopters could avoid the limits of terrain and enemy actions simply by flying over it. The workhorse of this war was the Bell UH-1, better known as the Huey. The Huey was used in all sorts of roles. It was mainly a troop carrier, but it could also be used to evacuate wounded troops. An armed gunship version, nicknamed the Hog, was the forerunner of today's attack helicopters. The Huey also served as the basis for the AH-1 Cobra, the world's first attack helicopter. The helicopter's vertical mobility makes it ideally suited as a military transporter. It has been an age-old desire of military tacticians to sneak large forces behind heavily defended enemy lines and surprise him where he least expects an attack. In World War II, this was accomplished using paratroopers. Paratroopers could be dropped out of airplanes hundreds of miles behind enemy lines, but it was very risky, and the paratroopers were at the mercy of the winds. The helicopter provides the same ability to move forces behind enemy lines, but allows the military commander to land the forces with precision. Once paratroops landed, they had to fight their way out. Helicopters provide the means not only to land troops, but to remove them once they've accomplished their mission. For this reason, the air mobile helicopter forces have gradually replaced paratroopers as the fast mobile force on the modern battlefield. helicopter's speed and maneuverability make it an ideal vehicle for scouting and reconnaissance. Helicopters have become the modern equivalent of the mounted cavalry, going out in front of armored divisions to look for enemy forces. Helicopters are not deterred by terrain. They can easily operate over mountainous areas, swamps, forests, or other features which would stop an armored vehicle. It's this quality that makes helicopters so invaluable as Army scouts. It didn't take long before soldiers began strapping guns on helicopters. The first armed helicopters took to the air with French troops in Algeria. But the proof of this concept came in Vietnam. At first, armed helicopter gunships were used to escort troop ships. Landing areas would be strafed to clear them of enemy troops before the troop-carrying helicopters arrived. Soon, helicopters were used as fire support weapons in their own right. Ironically, their slow speed is one of their main advantages. They can spot small targets easier than fast-moving jet aircraft can, so they are precise enough to attack enemy positions close to friendly forces. Nearly any kind of helicopter can be used as a gunship. Their capabilities in this role depend on their lift. The more lift, the more weapons they can carry. By the late 1960s, efforts were underway to design helicopters specifically for the gunship role. The weapons of gunships are numerous. The standard armament consists of an array of machine guns. On specialized gunships like the Cobra, a minigun is carried in a special turret on the nose of the aircraft. Helicopters can also carry rocket pods. Each rocket has the explosive load of an artillery projectile, giving the helicopter as much firepower as a small artillery battery. The world's first attack helicopter was the United States Army's Bell AH-1 Cobra. The Cobra was developed during the Vietnam War on the basis of the legendary UH-1 Huey transport helicopter. The Huey could be armed with guns and rockets and was often used in the gunship role during the Vietnam War. But this was an improvisation. By redesigning the forward fuselage of the Huey, its effectiveness in the attack role could be considerably increased. This led to the Cobra. The Cobra pioneered the classic attack helicopter configuration. In the forward cockpit is the co-pilot gunner, and in the rear cockpit is the pilot. This tandem configuration results in a sleeker fuselage than conventional transport helicopters, permitting greater speed and maneuverability. The Soviets followed the United States example with their Mi-24 Hind attack helicopter. In the 1970s, the role of the Cobra shifted. The early version was armed primarily with machine guns and rockets. The advent of more effective guided anti-tank missiles, such as the American TOW, greatly expanded the importance of attack helicopters. Helicopters were ideal anti-tank missile carriers. Their mobility in the air allowed them to exploit terrain to find the best location for launching the missiles. Tank hunting became one of their primary missions. The attack helicopter has also had its impact on marine operations. The Sea Cobra is a marine variant of the Army's Cobra. The Sea Cobra saw extensive combat with marine helicopter squadrons during Operation Desert Storm. The Marine Cobras differ from their Army counterparts in their engine type and in other features, since they often operate in a very different environment. The Marine squadrons operate either from Navy amphibious assault ships or from land bases. Sea Cobras and their improved variants form the backbone of Marine attack helicopter units. One of the latest improvements in marine attack helicopters is the more powerful AH-1 Whiskey Super Cobra. The Super Cobra can fire either the TOW or the newer Hellfire anti-tank missile. In the U.S. Army, the Cobra is still used, even though more advanced attack helicopters, such as the Apache, are now in service. The Cobra saw extensive use with cavalry squadrons during Operation Desert Storm. It is still a very effective combat helicopter for many roles. Attack helicopters bridge the gap between armored vehicles and jet strike aircraft. They have greater mobility and speed than armored vehicles, even though they lack their armor protection. They cannot carry as much ordnance as fast and as far as strike aircraft, but their rotor propulsion allows them to be operated from the forward edge of the battlefield. Combat helicopters are often part of the Army rather than the Air Force. This close connection between the helicopters and the ground forces make them particularly well suited to carry out treacherous cavalry missions. A good example of this is the U.S. Army's latest attack helicopter, the AH-64 Apache. The 1980s saw the deployment of the first attack helicopter designed from the outset for the anti-tank role. This was the AH-64 Apache. The Apache was designed to fight and survive on the modern battlefield. A new generation of missiles, missile guidance, and advanced sensors gave the Apache unprecedented long-range firepower. At the center of the Apache's weapon systems is the Hellfire missile. The Hellfire is laser-guided rather than wire-guided. Older wire-guided missiles have a maximum range of about 2 miles due to the length of the wire that can be carried. The Hellfire's range is more than double. This is made possible by its unique guidance system. A laser designator mounted in the nose is aimed at the target and fires an invisible beam of intense light at the enemy tank. A seeker in the head of the Hellfire can sense the laser light being reflected off the target. It homes in on this laser reflection with pinpoint precision. This longer range is a critical advantage for helicopters. This allows the helicopters to attack from positions more than 5 miles away from the enemy. By attacking at standoff ranges, the Apache minimizes its own vulnerabilities to enemy defenses and maximizes its own advantages. The Apache is designed not only to engage tanks, but other types of targets as well. So it's armed with a variety of other types of weapon systems. Under the nose of the helicopter is a 30-millimeter chain gun, which can be used against lightly armored vehicles. On the stub wings are unguided rockets for attacking targets with high explosives. Helicopters are large and noisy. To minimize the visibility of the Apache to enemy forces, it was designed to operate at night. The two unusual devices on the nose of the Apache are the Target Acquisition and Designation System, or TADS, used to aim and target the Apache's weapons, and the Pilot's Night Vision System, or PNVS, used by the pilot to fly the aircraft at night. Both the nose-mounted sensors contain forward-looking infrared sights, or FLIR for short. The FLIR works like a television camera, but senses heat rather than light. The supercooled sensor of the FLIR can detect a few degrees of temperature difference between objects, making it an ideal night sight. The advantages of night flying became apparent to the Apache crews who flew during Operation Desert Storm. Flying an attack helicopter at high speeds, at low altitude, and in a hostile environment is difficult and risky. The Apache cockpit is highly automated to simplify the pilot's tasks. This makes it easier for the pilot to concentrate on the hazards of the battlefield. One of the most remarkable features of this system is a sophisticated helmet sighting system. The unusual helmet we see here is called the IHADS, for Integrated Helmet and Display Sighting System. It allows the crewman to aim and operate the guns merely by turning his head.
The entire system is really very easy, although it seems very complex. Basically what we have is the pilot wearing the helmet, either the front seater or the back seater, and on either side of his helmet we have detectors that detect infrared radiation. Well, behind the pilot's seat and the co-pilot seat we have two emitters that send out infrared radiation to the pilot's helmet. These detectors pick it up and all that information is fed into a computer, and the computer just triangulates how long it took for the ray to get from the emitter to the detector, and then it says, okay, the guy must be looking in this direction, and then points the gun in that direction. And the gun is so accurate that if it's off more than 3 degrees from where the pilot's looking with his naked eye, then it'll shut the system down and you can't use it. And these are the infrared detectors I was telling you about, and there are two on each side of the helmet, and they both look like small light bulbs. But if you look closer, they're a small prism-looking device, and they pick up the infrared radiation coming from the emitters. And of course, the helmet has a clip on the right-hand side, and that's for a HD or a helmet display unit. What we do is we clip this display onto our helmet, and it rotates down in front of our right eye, and we have a monocle that we look through, and that gives us various FLIR imagery, TV imagery, and our different symbols and that sort of thing.
The IHADS helmet not only drives the gun, but also controls the sighting devices in front of the helicopter as we see here. Notice that as the pilot moves his head, the gun and sensors move in parallel. This makes it much easier for the crew to aim the weapons during high-speed evasive maneuvers near the ground. The latest version of the Apache is codenamed Longbow. The bulbous sensor mounted on top of the rotor assembly is a millimeter wave radar. This sensor expands the all-weather capabilities of Apache even beyond FLIR sensors. It also permits the use of a new generation of fire-and-forget Hellfire missile using millimeter wave guidance. Such a Hellfire will not need laser designation, but can home in on the target using its onboard sensor. This combination of advanced technology and novel tactics has made the Apache attack helicopter one of the most potent weapons in modern land warfare. The success of attack helicopters like the Cobra and Apache has inspired similar helicopter programs around the world. Probably the least known of these is the Rooivalk, developed in South Africa. The South African Defense Forces were prompted to develop a sophisticated attack helicopter due to their combat experiences with troop helicopters in the 1980s, especially the fighting in Angola. The layout of the Rooivalk is the classical configuration with a two-man crew. One of the differences between the Rooivalk and the Apache is the cockpit layout. The Apache uses a single canopy, while on the Rooivalk seen here, the canopy is split. Unlike the Apache, the pilot sits in the front cockpit and the weapons officer in the rear. The armament system of the Rooivalk is similar to the Apache's. The Rooivalk takes advantage of new computer interfaces to permit the mounting of a wide variety of weapons options, depending on the mission. Although the basic concept of the Rooivalk is very similar to the Apache, it differs in many details to make it better suited to operating in the African environment. Its design follows the Apache by almost a decade, which has enabled its developers to incorporate several new technologies. The Royfalk is the most sophisticated aircraft ever developed in Africa and displays a level of technological sophistication found in European or American designs. The effort that went into this helicopter is clear evidence of the growing importance of the helicopter in contemporary military operations. Despite the powerful capabilities of paratroops and helicopters, the ability to move ground-based troops quickly to the heart of the battle remains central to the mission of the cavalry. Automotive advances led to the development of thickly armored wheeled vehicles capable of greater speed, able to move swiftly into battle, or safely scout large areas in short order. Today, these wheeled vehicles form the land-based arm of the winged cavalry. The most remarkable new American armored car is the V-600 Commando. The V-600 was designed to offer the firepower of a main battle tank with the simplicity and low cost of an armored car. New advances in automotive technology gave vehicles such as the Commando much higher road speeds than tracked vehicles, over 55 miles an hour. The V-600 is armed with a 105mm gun, identical in performance to the gun used on American main battle tanks, such as the M60 and the M1 Abrams. The V-600 Commando has far more sophisticated fire controls than previous armored cars, which allows it to fire while on the move. Rapid Response has a more favorable view of fast-wheeled armored vehicles than does the U.S. Army. In the 1980s, the Marines began looking to give their divisions additional speed and mobility in a light armored vehicle. They selected an interesting design, manufactured by General Motors of Canada. The Canadian design originated in Switzerland as part of the Piranha family of wheeled armored vehicles. The Swiss Movag firm developed a family of wheeled armored vehicles using 4, 6, or 8 wheels, depending on the mission requirements. The Movag Piranha family was designed as a state-of-the-art wheeled armored vehicle, capable of operating in terrain conditions that would stop many other wheeled armored vehicles. The Piranhas can be armed with a variety of weapons, ranging from simple machine gun turrets to elaborate turrets with large caliber tank guns. The U.S. Marine Corps selected the 8-wheeled version of the Piranha family. The basic American version is called the LAV-25. It's armed with a 25mm Bushmaster automatic cannon, the same weapon used on the Army's Bradley infantry fighting vehicle. Besides its 3-man crew, the LAV-25 can carry an additional 6 Marines in the rear compartment. Because of its speed and mobility, the LAV-25 is used for scouting, raiding, and screening operations, where its mobility can best be exploited. They often moved swiftly in advance of Marine mechanized formations, hunting out weak points in the enemy positions, much like traditional cavalry. They offer the scouts the advantage of armor protection, as well as considerable mobility. The Marine Corps' interest in the fast-moving LAV is closely tied to its traditional role in American rapid deployment missions overseas. These tasks require a special accent on mobility. This led the Marines to seek a vehicle lightweight enough to be easily moved by air, yet well enough armed to have impact on the modern mechanized battlefield. A specific Marine requirement was the need to have the LAV light enough to be airlifted by the CH-53 Echo Super Stallions. The Super Stallion can lift the LAV for considerable distances, even refueling in midair to extend its range. After flying into battle, the winged cavalry must carry out its mission on the ground. The LAV has been tested for its suitability for parachute airdrop missions. It takes quite a set of parachutes to safely land a 12-ton LAV. As the vehicle of choice for carrying out the cavalry's ground mission, the LAV is also well suited for delivery by Lapes, as seen in this test footage. The LAV was put to the test in combat during Operation Desert Storm. The conditions in Saudi Arabia, with its hard desert soil, proved well suited to the LAV's wheeled configuration. LAVs were used in many engagements, from the first encounters with the Iraqi forces in the battle at Khafji in January 1991 to the final assault into Kuwait City in February. The LAV gave the Marine Corps the advantages of a fast-moving traditional cavalry force covering its flanks and probing enemy positions. Speed and mobility on the ground has always been essential to the South African Army. For a decade, South Africa was involved in conflicts along its northwestern border in Namibia with guerrilla forces and the regular armies of Angola and Cuba. South African forces have had to travel hundreds of miles with little technical support to carry out these missions. Wheeled armored vehicles provided the mobile shock force for these missions. South Africa first manufactured the Marmon Harrington armored car in World War II, and it saw extensive use in the North African desert campaigns. In the 1960s, they began production of the Eland armored car, based on the French Panhard AML. The Elands proved to be extremely successful. In a number of skirmishes with Angolan forces, Elands were able to knock out more powerful Soviet-manufactured T-55 tanks by exploiting their speed and mobility. The South Africans have favored wheeled vehicles for their range advantages and economy. The first local South African armored car design was the Rottle, designed primarily as a troop carrier. The Rottle is a large vehicle, capable of carrying troops and turreted weapons, including anti-tank missiles and guns. The Rottle is very high off the ground compared to its European counterparts. The South Africans have found that sleek European armored vehicles, riding close to the ground, have problems in African conditions. So too have opposing forces using Soviet-built vehicles. The most ambitious South African armored vehicle to date has been the Rooikat. In many respects, it is the ultimate cavalry armored vehicle. The South Africans have a different conception of contemporary warfare than European armies due to their past combat experiences. They distinguish two general types of combat: high mobility operations requiring a modern form of cavalry, and high intensity operations requiring European-style tank forces. High mobility operations, resembling classic cavalry actions of the past, were the predominant type of combat fought by the South African Defense Forces against Angolan and Cuban troops. The Rooikat was specifically designed to cover great distances quickly. The Rooikat's armament is a stabilized 76mm gun. This is lighter than the guns found on current European armored cars, but the emphasis is on speed rather than firepower. The South Africans have found that such weapons are more than adequate for the types of enemy vehicles they've typically engaged in past wars. Wars in Africa usually involve formations of light armored vehicles. Heavy tank formations are far less common than in European or Mid-Eastern armies. South African armored vehicle designs like the Rooikat incorporate special features to help reduce their vulnerability to landmines. They can continue to operate even after one or more wheels have been destroyed. The Rooikat is a clear demonstration of the continuing need for wheeled cavalry, not only on the plains of Europe, but on the velds of southern Africa as well. The first armored cars were built in Europe, and not surprisingly, they still are being developed there. Italy has a long history of armored car design, from the early Ansaldos of World War I to the AB-41, famous in the North African desert campaigns of World War II. In the 1990s, the Italian Army turned to an armored car design called the Centauro to form the backbone of their new rapid deployment units. The Centauro brigades are designed as the mobile reserve force of the Italian Army. They're able to move from bases in central Italy to distant locations on a moment's notice to reinforce forward deployed Italian units. This role places an emphasis on firepower and mobility over armor. The Centauro's gun gives it the firepower to destroy most existing main battle tanks. Centauro units use tactics and terrain for protection rather than armor alone. Chemical warfare was one of the factors that led to the demise of horse cavalry. The German army uses an armored car to defend against chemical weapons. The Fuchs is a chemical scout vehicle designed to locate and identify the enemy use of chemical warfare agents. The vehicle is hermetically sealed against agents and contains its chemical sensors inside. It has a special external probe which can be used to pick up contaminated material outside the vehicle and bring it into an interior compartment without exposing the crew. The chemical sensor equipment inside can distinguish between a variety of chemical warfare agents. France has been more active in wheeled armored vehicle design than nearly any other country in Europe. Since the 1960s, French armored cars, including the Panhard, have been exported around the world. In the modern cavalry reconnaissance role, the French Army has adopted the AMX-10RC in recent years. Like the Centauro, it's armed with a 105mm gun, and the AMX-10RC played a major part in France's commitment to Operation Desert Storm in 1991. The French Army has adopted a mixture of tracked and wheeled vehicles to transport its infantry in combat. The VAB is the wheeled element of this force. The VAB carries a standard infantry squad in the rear. It's been designed to carry a wide variety of weapons turrets, ranging from machine gun turrets to specialized missile turrets. The missile turret can include anti-tank missiles, such as the HOT. The VAB was designed in a modular fashion to provide other configuration changes. The most radical of these is the VBC. It shares common chassis elements with the VAB, but is designed primarily as a cavalry reconnaissance vehicle. Wheeled vehicles were the pioneers of modern armored vehicles. The chariots of ancient warriors have been replaced by the modern armored cavalry. After generations of using the horse for mobility, today's cavalry flies to the forward edge of battle. The high-speed armored car, the paratrooper, and the combat helicopter all perform the missions formerly undertaken by the horse cavalry. When a rapid reaction force is needed for today's high-speed maneuver warfare, the call goes out for the winged cavalry.